Hello dear students, in this video we are going to see Design and Analysis of Algorithms Lab exercise N Queen's problem. You all might have experience of playing chess where we have king, queen, ministers, horse, elephant, etc. Here in this N Queen's problem, we will be given N cross N chessboard with N queens. It is not restricted to 8 cross 8 and it is not restricted to 2 queens. So here we have N cross N chessboard with N queens. Say for example, if we have 4 cross 4 chessboard is given, then we will be having 4 queens and we have to place this 4 queens in this 4 cross 4 chessboard so that no queens will attack each other. The queens can move horizontally, vertically and also in diagonally. So we should not place 2 queens in the same row or in the same column or in the same diagonals. So this is what the constraint when we place this N queen in this N cross N chessboard. So for example, now let us consider if we are given with 1 cross 1 chessboard. If we have 1 cross 1, then we'll have 1 queen. So there is obviously no problem in placing the queen and there will not be any clash. Let us consider this 2 cross 2 chessboard. So if it is 2 cross 2, we will be given with 2 queens. For example, if you place the first queen here in this first cell, let us keep this first queen in the first cell means then what will you do? We will be the second queen will be, if I place the second queen in this place, this queen will vertically clash with the first queen, and if I place the second queen in this place, it will be diagonally clashing with the first queen. And for example, if I place the first queen in the second cell, then what happened? The first queen I cannot place it, the second queen I cannot place it here because it will diagonally clash with the first queen, and if I place the second queen in this cell, it will vertically clash with the first queen. So there is no solution to place this 2 queens in this 2 cross 2 chessboard. And for example, if the chessboard is of 3 cross 3 here in this case, so we will be given with 3 queens. So if I place the first queen in this cell and if I place the second queen in this cell, it will vertically clash with this queen. And if I place this here, the second queen in this place, it will diagonally clash. Okay, and if I place the next queen here, so it will, if the first queen is already there, we have considered, so it will definitely clash vertically. And if I try to place this queen in this place, if the second queen, if we have placed it here, it will definitely diagonally clash it with the second queen. And if I place the third queen in this cell, it is definitely clash diagonally with the first queen. So considering if I have placed the first queen in this place, so if I work with 3 cross 3 chessboard and with 3 queens, there is no solution to place this 3 queens in this 3 cross 3 chessboard. So for the number n, so there is no solution to place this n queen if we have the chessboard less than 4. So less than 4, if we have the chessboard size, then there is no solution to place this n queens. So whenever we solve n queens problem, the chessboard size should be greater than 3, then only we can find the solution for it. If we take 4 cross 4 chessboard, or if you take 8 cross 8 chessboard, this is what the solution for placing this 4 queens here in this case and 8 queens in this place. And the mirror image of this 4 cross 4 chessboard will also be then another solution for this chessboard. Not only this, the mirror image of this will also be the next solution. And the same thing for 8 cross 8 also. The mirror image of this 8 cross 8 chessboard will be the next solution. And not only that, for the 8 cross 8 we have many more solution for it. So this is one solution. And so here if you see, no two queens will attack each other. No queens two queens are placed in the same columns or placed diagonally or in the same row. So this is how we have to place n queens in the n cross n chessboard. So let us see an example of working with n cross n queen when we place it in the 8 cross 8 chessboard. So if we are given with a 8 cross 8 chessboard, then there will be given 8 queens. So let us do one by one. So how we have to start it? First take the first queen and try to place it in the first cell. So first available square we can place that particular n queen. So let us take the first queen. So for the first queen, the available cell for the first queen is this place. So here we have kept the first queen. And next we have to place the next second queen in the next available place. So we cannot place it in the same row. So let's go to the next row. And I cannot place the queen in this place because it will vertically clash with the first queen. And I cannot place the queen in this place as well because it will diagonally clash with the first queen. And if I place the second queen in this place, then it will not clash with any other. So we are placing the second queen in this place. Let us take the go to the third queen. So third queen I cannot place it here because it will vertically clash with the first queen. If I place it here, it will diagonally clash with the second queen. If I place it here, it will diagonally clash with the first queen. And if I place it here, it will diagonally clash with the second queen. So I can place it in this place. Then now we have to place the next queen in the next available place. So here if I place the fourth queen, it will clash vertically with this first queen. And if I place it, the fourth queen in this place, it will not clash with any other. So we will place it here. And then let's move to the fifth queen. So it will, if I place the fifth queen in the first cell of this row, it will clash it with the first queen. If I place it here, it will clash it with the fourth queen. If I place it here, it will vertically clash with the second queen. If I place it here, there will not be any clash. So we are going to place the fifth queen in this place. Now the next thing is we have to place the sixth queen. So if I place the sixth queen, here I cannot place because it is vertically clashing with the first. Here it will clash with the fourth queen, and here it will clash with the second queen. Here if I place, it will clash with the fifth queen. Here if I place, it will clash vertically with the third queen. And here if I place, it will diagonally clash with the first queen. If I place it here, it will diagonally clash with the second queen. And if I place it here in this cell, it will diagonally clash with the third queen. So there is no solution in this row to place the sixth queen. So whenever there is no solution to place this particular queue, then what we have to do is we have to do the backtracking. So we have to go back to the previous queen, and then we have to find the next available or next possible solution for the previous queen. So we are going to the fifth queen. So we are going to find the next possible place for this fifth queen. So here I cannot place the fifth queen because it will diagonally clash. Then here if I place, it will diagonally clash with the second queen. And here if I place, it will diagonally clash with the third queen. And if I place it here, then there is no clash for the fifth queen. So we are going to place the fifth queen in this place. Right? So likewise we have to continue. So now then we have to continue for the sixth queen, and we have to find the possible suitable solution for it, and it will keep on continuing like this. So this is how we have to solve the n cross n chessboard with n queens. So let's see one example. So let's see an example of backtracking solution for n cross n chessboard. So here we are going to do for 4 queens, which means for 4 cross. So here we are having 4 cross 4 chessboard, and we will be given with 4 queens. So let's start. So how to start it is, first we have to start with the first available place, right? So let me put the first queen in the first available cell here. So Q1 is placed here, and the next queen we have to start here. So if I place the second queen in this place, it will vertically clash with the first queen, and if I place the second queen in this cell, this will diagonally clash with the first queen. So if I place the second queen in this place, it will not get clash. So we are going to put the second queen in this place. Okay, let us move to the third queen, and if I place the third queen in this cell, it will vertically clash with the first queen, and if I place it in the second cell, it will diagonally clash it with the second queen, and here if I place it will vertically clash with the second queen as well as diagonally clash with the first queen. And if I place the third queen in this cell, again it will diagonally clash with the second queen. So there is no solution for the third queen to be placed in this particular row. So what we saw in that algorithm, whenever there is no solution, then we have to do the backtracking. So we are going to backtrack, and here we are going to find the next suitable place for this Q2. The second queen. So if I try to put the second queen in this place, this is the next possible place for the second queen to place. So I am putting it, and then I am coming back here, and I am going to see whether I could able to place the third queen. So if I place it here, it will vertically clash with the first one, and if I place it here in this place, it will not clash with anyone. So I am going to place the third queen in this place, because it will not clash diagonally with anyone, and it is not clashing vertically with anyone. Okay, now let us go to the fourth queen and try to place it. If I place the fourth queen in this place, it will clash with the first queen vertically. Here if I place the fourth queen in this cell, it will vertically clash with the third queen. Here if I place it, it will diagonally clash with the third queen, and if I place the fourth queen in this place, again it will vertically clash with the second queen. So again we don't have any solution to place the fourth queen. So what we have to do according to the algorithm, we have to backtrack. So when we backtrack, go back here, and we have to find the next possible solution for the queen number 3. And if I try to place the queen 3 in this place, again it will clash diagonally with the second queen, right? And then if I try to place the third queen in this cell, it will vertically clash with the second queen. So there is no solution for placing the third queen again. So what you have to do, again go do the backtracking and go to the second queen. And if you see the second queen, there is no other solution for the second queen to move, right? So again there is no other place to move the second queen. So what we have to do, again backtrack and go back to the first queen, and then we have to find the next possible or available place for the Q1. So instead of placing it here in this cell, we are going to find the next possible place where we can place the first queen. So here the queen 1 can be placed in this place, right? And then second queen I cannot place in this place, it will diagonally clash. Here I cannot place, and here I cannot place, it will diagonally clash with the first queen. So here I can place the second queen. So I am going to place the second queen here in this time. Okay, then let us move with the third queen. So if I place the third queen in this place, it is not clashing with anyone. So it is not clashing vertically with anyone, it is not clashing diagonally with anyone. So I can place the third queen in this place. And then we have to place the fourth queen. If I place the fourth queen in this place, it will vertically clash with the third one. If I place it here, it will vertically clash with the queen 1. And if I place the fourth queen in this place, it is not vertically clashing with anyone, and it is not diagonally clashing with anyone. So I can place the fourth queen in this place. Okay, so this is what the solution we have finally for this n cross n queen problem, which means here we have taken the n as 4. So we have placed 4 queens in the proper position without clashing each other or without attacking each other. So whenever there is no possible way of placing a particular queen, then we have to backtrack to the previous queen and we have to find the next suitable or available place for the previous queen, and we have to find the solution accordingly. So now let us discuss the algorithm for this backtracking solution for n cross n problem. So before, this is what the hierarchical or tree structure of solving this 4 cross 4 queens problem. So here we are first, when we place the first queen in the first solution, and to place the second queen, these are the possible solutions, and here we have no other place, and if you place the queen in this place, the next possible place for the third queen is here, and then if I try to place the fourth queen, we have a problem. So we backtrack again and we came to the first queen and we found the next possible place for the first queen, and then again we place the remaining queens and we found the solution. So this is what the backtracking solution for the 4 cross 4 queen. Okay. So this is what the algorithm for solving this n cross n queen chessboard problem. Okay. So first of all, if you see in this algorithm, the algorithm is called with the parameter k and n. So what does this k specifies? The k specifies the which queen. For example, if we take a 4 cross 4 chessboard, so first n is 4, okay, and what is k? First we have to take the first queen. So this specifies which queen, and this specifies the n value, which means, so there for the one particular queen, for the first queen, there are 4 possible solution, and for the next queen, if we pass for the next find the solution for the second queen, again we have 4 possible solutions. There are 4 available places for each and every queen, right? And we have to find which position is suitable for this particular queen. So if for the first time we are going to take the first queen, and it has 4 possible places to be placed. And then when you come inside the algorithm, we have a for loop. So for every queen we are available, we have to check whether it is suitable for the position suitable for 1 to n. So that is why we are calling for every queen we have a possible place from 1 to n. And then when you come inside, so first we have the queen k value is 1 for the first queen, and then we are going to I value is 1. Now we have to find whether for the first queen the first position is suitable to place or not, or is there is any attacking or clashing happen when I place the first queen in this first position. So that we have to check. To check, we have another algorithm, and this is another algorithm which calls next algorithm place, to find the suitable position for this kth queen. And so it is coming here. So in this case, here the k value is 1, and we want to check whether for the first queen, whether the first place is suitable or not. Okay, and then now when you come inside this, again this for loop is going, and here what you have to do means, if I want to check whether I can place this particular kth queen in a particular position I, means it should not clash vertically or horizontally or diagonally with any other queens. So then if it is not clashing or attacking, then only I can place this particular queen in this particular position. So that is what checked in this particular algorithm place. So here we have to check for the previous queens. For example, if I am placing the first queen here, and if I am placing the second queen here, and then when I want to place the third queen in this place, in this time, I have to check whether can I place this third queen in this position I, which means this is the position, right? 1, 2, 3, 4, the columns, the end columns. So I have to check whether the third queen's position, if I place in first position, is it suitable or not. But we know that this, if I place the third queen in this position number 1, it is vertically clashing with the first queen. So how will we find it is, here we have an array X. Okay, in the array X, every time we are placing the correct position of a particular queen. For example, when the first queen 1 is placed in this first position, then how does the array looks like is? So for the queen number 1 in the first position, we have placed the first queen in the first place, and then for the second queen, we have found the suitable position for the second queen in the position number 3. So when I want to find for the third queen which position to place, so I have to check in this array whether this position number 1 is already utilized or not. So if you see here, if you, for this case, it will come, and for example, if you consider this k value is 3 and the position number is 1, I want to check, can I place the third queen in the position number 1, means it will come here and check for the previous 2 queens. What are the previous 2 queens for the third queen? Queen number 1 and queen number 2. So I have to check for the previous 2 queens, have we used this position number 1? And here if you see in this array, the position number 1 is already used for queen number 1. So we cannot place it. So that is what checked in this. So the J will be going from 1 to k minus 1, which means for the third queen, we have to check the previous 2 queens, right? So it will be going from 1 to 2, the previous 2 queens. And then when it comes inside the for loop, it will check for the jth queen. For this 3, for every time it will be checking for the first time whether it has this particular position 1 is already available or not. So if the particular, this is what the position we want to check, right? For the third queen, does this position number 1 is suitable or not? So if we check in the first position x of 1 itself, we will be having the position number 1. So we will be knowing, okay, the position number 1 is already utilized by some other queens, the previous queens. So if we cannot use the same position. And so what we'll do, if the condition become true, then it will return false. So it will be coming back here, and this condition fails, right? So it will be coming back and it will be going for the next I value, and then it will come with for the queen number here in this case, it will go for queen number 3 with the position number 2, and then it will check for the queen number 3 position number 2 is suitable or not. So it will come back here again for the queen number 3 whether the position number 2 is suitable or not. So we will be checking 2. So if we go inside this for loop, and if you see in this X array, 2 is already not available, so that we can place this queen in this particular cell. So this is how this condition is checking. So this condition will check whether any other queens are available in the same particular column. Okay, so what is this is what the condition for checking whether vertically, right, any other queens are available in the vertical position. Now we have to check whether there is any clash diagonally, right? So that is what we are going to see. For example, if you consider, we are going to consider that the first queen is in this position, position number 1. So this is 1, 2, 3 and 4, and you know that I cannot place queen in this place, right? Why I cannot place a queen in this place? If I place a queen in this place, this will diagonally clash with the first queen. Okay, so how can I find whether it is diagonally clashing or not? Means here we can check it by the horizontal distance and the vertical distance. If both are same, then we can find, or then we can say these two queens are diagonally clashing with each other. right? So not only in this case, for example, we'll take another case also. Let us take one more case. So if I place the second queen, you consider the second queen is placed in this place, and if we cannot place the fourth queen in this place, right? In this case, why we cannot place? Because it will diagonally clash with one another, so we cannot place. So how will we find it? So we know that the horizontal distance and the vertical distance, if between these two queens, if both are same, then we can find that they are in a diagonal position and we cannot place it in this particular position. So to check it, how we are going to check? So that is what the condition placed here. So what is the first condition? It says this conditions check whether it is check the horizontal distance. This will check the horizontal distance, and this condition will check the vertical distance. If both the horizontal and vertical distance are same, then I know that they are they are diagonally placed, or in the diagonal, they are in the diagonal position, so we cannot place it in that particular position. So what is there? First condition says x of j is equal to I. What is x of j? That is, if any of, or if you consider in this second queen here, if you consider q2, if we are checking for the fourth queen and we want to check whether any other queens are diagonally clashing with the fourth queen. So in this particular scenario, what is x of j? So we are going to x of j here is the previous queen. This says j says about the previous queen, right? So the previous queen here is 2. Okay, x of 2. Whether, and what is I, and we want to check whether this particular position is suitable or not. So which position is suitable we are checking? The ith value we are checking here is 4. I am checking whether the queen number 4 can be placed in the fourth position or not. So here the value is 4, and if you find the distance, we will be getting 2. The distance between these two is 2. So this is one condition. So and now we found the horizontal distance, we got the horizontal distance as 2. Now we want to find the vertical distance as well, right? So how to check the vertical distance? J and K are checked, and we are going to find the difference. So what is J? J is the previous queen. This is jth value and this kth value, and if you want to, and we want to find the distance between these two, so k means now the current queen. So the current queen we are going to check is 4. So j is 2, the previous queen we are going to check whether this previously available queen 2, and the presently checked queen, that is a k, right? The presently checked queen is 4, and if you find the difference between these two, the difference is again 2. So if you find the horizontal distance and the vertical distance is now 2, both are 2, they are equal. So if the horizontal distance which we checked here and the vertical distance which we checked here, both are now equal. So if horizontal distance and the vertical distance, if both are same, then we can know that the queen number 2 and the queen number 4 are placed diagonally and they will attack each other. So if they are same, then again it will return false. So this particular position 4 is not suitable to place the queen number 4. So then it will return false. So it will come back and it will do the backtracking again in this case. So if you come inside, so if it is suitable, then that particular I position is the place we are checking every time, right? Whether this particular I is suitable to place this queen number k. And so if it is suitable, then this I value, this I, right? This is what I will be placed in this particular array position. And then we are checking that we have to check whether the k reached n, because we have to check for all the possible all the queens, right? So we have to find for all the queens. If it is a 4x4 chessboard, we have to check it for all 4 queens at the proper place, and then after finding it, then we will be printing the solution. Otherwise, we have to else we have to call back, we have to recursive call for the next queen. After finding the solution for 1 queen, then we have to, if we are not checked for all the n queens, then we have to, for example, if we find the solution for the queen number 2, then we have to find the suitable position for queen number 3. So here next time k plus 1 and all the n possible solution, n possible places are given for the next function call, right? So this is how this algorithm is working. So what is the input for this algorithm? The input for this algorithm is n. What is the size of the chessboard and how many number of size of the chessboard and how many number of queens. So that is the input. And what is the output? We have to say the position for the n queens. So here for this n queen, which means here we have taken the n value as 4. If we have taken the n value as 4, then the output will be getting this X array, where we will be getting, if you remember in the previous slide, we found the solution for 4 queens where we can able to place in this 4x4 chessboard, right? So what was the solution we found? If you remember, it is the first queen we can place it here, and the second queen we can place it here, third queen we placed here, and the fourth queen we placed here, and it will not clash or attack any other, right? So the solution for this is, the first queen is placed in the position number 2, second queen is placed in the position number 4, third queen is placed in the position number 1, and the fourth queen is placed in the position number 3. So this is what one solution we got for this 4x4 queen, to place the 4 queen in this chessboard. Hope you got it. And since we are repeating for 1 up to n, it will give you all possible solution to place this 4 queens in this 4x4 chessboard. Hope you got it. Thank you.